Observability and SRE Part 3. This episode has 12 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. Cloud migration. Today interview July 6, 2026. AWS to GCP migration. Suppose a client has an application running on AWS. How would you migrate it to GCP across discovery, network, IAM, database, storage, CI or CD, validation, cutover, and rollback? Here's a strong way to approach it. Start with discovery, inventory services, dependencies, traffic, data size, RTO or RPO, compliance, and current IAC. Map AWS constructs to GCP equivalents, VPC or subnets or security groups to VPC or firewall rules, IAM roles to service accounts or IAM bindings, S3 to cloud storage, RDS to Cloud SQL or Alloy DB, X or ECS to GKE or Cloud Run, CloudWatch to Cloud Operations, build landing zone, networking, IAM, logging, and CI or CD first. Migrate data with replication where possible. Run parallel validation. Deploy the app in GCP using immutable artifacts. Test functional, performance, security, and DR paths. Then cut over gradually through DNS, load balancer, or traffic splitting. Keep rollback ready by leaving AWS healthy until GCP has passed agreed success criteria. Nice. Let's continue. Question 2. Terraform or IAM incident. Today interview July 6, 2026. Terraform IAM recovery. A Terraform change accidentally removed production service account permissions. How would you debug and recover? Here's a strong way to approach it. Treat it as an incident first. Stop further applies. Identify impacted service accounts and customer impact, and restore the minimum required permissions quickly from a known good plan. Previous state, audit logs, or a break glass runbook. Check CI or CD logs. Terraform plan or apply output. State history, Git diff, provider change, and cloud audit logs for set IAM policy or binding changes. If workloads are down, temporarily regrant least privilege roles manually or through an emergency Terraform patch. Then validate services recover. After mitigation, fix the root cause. Avoid authoritative IAM resources where additive bindings are safer. Add policy as code checks. Require plan review for IAM diffs. Isolate state blast radius. And add tests that detect removal of critical bindings. Great. Moving on. Question 3. Platform architecture. Today interview July 6, 2026. Multi-environment architecture. Design a multi-environment architecture for dev, QA, and prod. Here's a strong way to approach it. Use separate projects or accounts per environment, with clear folder hierarchy, separate IAM, separate Terraform state, separate service accounts, and environment-specific network boundaries. Dev can be lower cost and more permissive for experimentation. QA or staging should mirror prod topology closely enough for reliable testing. And prod should have stronger approvals, HA, backup, monitoring, and access controls. Reuse the same Terraform modules and deployment templates across environments, changing only inputs such as sizing, replicas, CIDRs, retention, and approval gates. Alright, next question. Question 4. Terraform or IAC. Today interview July 6, 2026. Terraform state isolation. How would you isolate infrastructure and Terraform state across environments? Here's a strong way to approach it. Use separate state files or backends per environment, separate backend paths or workspaces with strict naming, separate credentials or service accounts, and ideally separate GCP projects or folders. Keep shared modules versioned separately from live environment code. Limit each state file's blast radius by domain, network, IAM, GKE. Databases and app layers should not all be in one huge state if ownership and risk differ. Enable state locking, versioning, audit logs, and least privilege access to the backend. Let's keep going. Question 5. Kubernetes security. Today interview July 6, 2026. Network policy and admission control. How do you pair Kubernetes network policies with admission controllers? Here's a strong way to approach it. Network policies enforce runtime traffic rules, which pods can talk to which pods or external destinations. Admission controllers enforce what is allowed to enter the cluster in the first place. Together, they create defense in depth. Use gatekeeper or Kyverno or pod security admission to require labels. Deny privileged pods. Require namespace ownership. And require default deny plus approved allow policies. Then use network policies to enforce the actual east-west traffic boundaries. Admission prevents unsafe workloads or missing controls from being deployed, while network policy limits blast radius if something is deployed or compromised. On to the next one. Question 6. Incident response. Today interview July 6, 2026. Partial Terraform apply logs. During a production incident caused by a partially successful Terraform apply, what logs would you check first? Here's a strong way to approach it. Check the CI or CD job logs first to see the exact Terraform command, workspace, variables, plan file, provider versions, and resource address where apply failed. Then check Terraform state and plan output to identify which resources changed successfully and which did not. In parallel, inspect cloud audit logs for IAM, network, database, or compute changes, Kubernetes events if cluster resources were affected, and application or cloud logs for user impact. The goal is to build a timeline, what Terraform attempted, what the cloud accepted, what Kubernetes observed, and when symptoms started. Good. Here's another one. Question 7. Observability. Today interview July 6, 2026. Early incident detection. How would you design monitoring to detect customer impacting incidents early? Here's a strong way to approach it. Start from user journeys and define SLEs such as availability, latency, error rate, freshness, and successful transactions. Alert on symptoms users feel, high 5xx rate, page 95 or page 99 latency, failed payments, queue age, failed login, stale dashboards, or error budget burn. Add service level dashboards, synthetic checks, black box probes, and dependency telemetry. Cause-based alerts still help debugging, but paging should be tied to actionable user impact, clear ownership, and runbooks. Nice. Let's continue. Question 8. SRE or alerting. Today interview July 6, 2026. Burn rate alerts. What are burn rate alerts and why are they useful? Here's a strong way to approach it. Burn rate alerts measure how quickly a service is consuming its allowed error budget for and slow. Instead of alerting on a raw error spike, they ask whether the current error rate will exhaust the budget too quickly. Multi-window multi-burn rate alerting catches both fast outages, such as a severe 5-minute spike, and slow burns, such as elevated errors over several hours. This reduces noise and aligns alert severity with reliability impact. Great. Moving on. Question 9. Logging or tracing. Today interview July 6, 2026. Log correlation. How do you correlate logs across Kubernetes microservices? Here's a strong way to approach it. Use a correlation ID or trace ID generated at the edge and propagate it through every downstream call using headers such as traceparent or xRequest-ID. Each service writes structured JSON logs containing trace ID, span ID, request ID, service name, version, namespace, pod, user or tenant when safe, and error details. For async systems like pub or sub or Kafka, copy the trace context into message attributes. Then the logging backend can filter all logs for one request across services and connect them to distributed traces. Alright, next question. Question 10. Observability. Today interview July 6, 2026. OpenTelemetry basics. Explain OpenTelemetry. Here's a strong way to approach it. OpenTelemetry is an open standard and toolkit for collecting metrics, logs, and traces. It helps instrument applications in a vendor-neutral way. Detailed interview explanation. OpenTelemetry is part of production observability and monitoring. Observability helps teams understand what is happening inside complex systems using metrics, logs, traces, events, profiles, and alerts. The goal is not just collecting data. The goal is detecting user impact quickly and reducing time to diagnose and recover. Production example. For a Kubernetes microservice, a good observability setup collects request rate, error rate, latency, saturation, pod health, node health, logs with correlation IDs, and distributed traces across dependencies. Alerts are usually tied to slows or error budget burn instead of every low-level metric spike. Best practices to mention. Define SLEs and slows for important user journeys. Use structured logs and propagate trace IDs or correlation IDs. Alert on actionable user impact, not noisy symptoms. Control cost with sampling. Retention policies. And cardinality limits. Attach runbooks, dashboards, and ownership to important alerts. Common interview follow-ups. Expect questions about alert fatigue. Page 95 versus page 99 latency. High cardinality metrics. Log retention. Trace sampling. RCA. MTTA. MTTR. And how observability changes for Kubernetes or ML systems. Let's keep going. Question 11. Incident management. Today interview July 6, 2026. Outage decision making. During an outage with incomplete information, how do you decide whether to roll back, roll forward, use a feature flag, or shift traffic? Here's a strong way to approach it. Optimize for fastest safe mitigation, not proving root cause first. Roll back when the issue clearly started after a release and rollback is low risk. Roll forward when the fix is already known, tested, and safer than reverting, such as a small config patch. Use a feature flag when a specific feature path is causing impact and can be disabled without redeploying. Shift traffic when impact is region, cluster, version, or dependency specific and a healthy target exists. Communicate assumptions, set a time box, watch customer impact metrics, and keep a fallback if the chosen mitigation fails. On to the next one. Question 12. Similar scenario. Today interview July 6, 2026. Similar scenario Terraform plan review. What checks would you add before Terraform apply to prevent accidental IAM or networking breakage? Here's a strong way to approach it. Require saved plan review in CI, highlighting IAM removals, firewall exposure, subnet or routing changes, deletions, and replacements. Add policy as code with OPA or Sentinel to block public ingress. Broad admin roles, service account key creation, removal of critical IAM bindings, missing labels, or unapproved production deletes. Use least privilege Terraform service accounts, separate states, manual approvals for prod, drift detection, and tests for modules. For high-risk resources, add change windows and break glass rollback steps. Good, here's another one. That wraps up this episode. Nice work practicing, and see you in the next one.